Today we're going to learn about solving by elimination. Align the terms with the same or opposite coefficients, add or subtract the equations, substitute, and solve. So it seems like there's a lot of steps here, but the difference between elimination and substitution is in elimination, you're trying to eliminate one of the variables, so you're left with just one. I'll show you an example of how this works. So first we have to align the terms with the same or opposite coefficients. So what this means is you want to align two variables of the same value in order to make it easy to eliminate them when subtracting the equations. So in this first example, we have the y's basically aligned, and so we can now add or subtract the equations. The way you do that is by literally subtracting the equations from each other. So y minus y is 0. 3x minus 4x is going to be negative x. And 4 minus negative 10 is going to be 14. So now we're going to divide by negative 1 on both sides. And we're going to get x is equal to negative 14. That's going to be our solution for x. Now we need to take x and plug it back to one of the equations to solve for y. So let's do the first one. So we're going to have y plus 3 times negative 14 is equal to 4. Y minus 42 is equal to 4, which means y is equal to 46. And so the solution is going to be negative 14, 46. You'll always want to make the solution in terms of an ordered pair. So now for the second problem, the terms aren't aligned, so we have to align them. For the first equation here, let's add 5y to both sides. What this is going to do is have it so it's x plus 5y is equal to 6. So now this first equation is in a similar format of the second one here. If we move the equation right underneath, you can now easily see that the terms 5y are perfectly aligned. Now earlier I said that they need to be the same value, and that's ignoring the positive or negatives. Because in this case, what we're going to do is add the equations instead of subtract. The reason we add is because one of them is already negative, so it's going to cancel out if we add the equations together. All we want to do is make sure that by adding or subtracting the equations, we're going to eliminate one of the variables. In this case, 5y is getting eliminated. So that's going to be 0. 7x plus x is going to be 8x. And that's going to be equal to negative 60. Now let's divide by 8. And we're going to get x is equal to negative 7.5. Again, we need to plug this back into the equation to solve for y. So we're going to get negative 7.5 is equal to 6 minus 5y. Based on the first equation. So this is going to simplify to negative 13.5 is equal to negative 5y. And if we divide by negative 5, we're going to get y is equal to 2.7. So our point is going to be negative 7.5 and 2.7. Now for this last problem here, we're going to move around some of the variables to make both of the equations aligned with each other. So this first equation, we're going to subtract negative 6x from both sides. And so the first equation is going to be negative 6x plus 4y is equal to 12. And we see that it's the same as the second equation now. So if we were to do elimination, then we get 0 plus 0 is equal to 0, or 0 is equal to 0, which proves that in this case, the equations are graphically the same, and there's an infinite number of solutions.